Hi,
Hi, Eric,
everyone.
and warm welcome to Func Prog Sweden. We're
Thank
so,
you. Thank you.
yeah, you're welcome. We are,
Yeah,
yeah,
let,
you can hit it
let's
away,
start.
Eric. That's
Can,
it.
can 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 you see my slides?
We see your
Yes,
slides
now
perfectly
you
well.
can. Okay, that's fantastic. Yeah, so today I'm very happy to talk to you about a functional programming language called Unison, which is a functional programming language that I love, and how I use Unison to implement a command line parsing library called Potions. And if you wonder about the name, it's a not so clever anagram. Potions is just an anagram of options. That's how it came to be. So last year I was implementing oops, I'm trying to find a clicker. Yes, I was implementing some application using Unison, and I found myself wanting to pass arguments on the command line. And Unison in a way, is a fairly new programming language, so it doesn't have the whole ecosystem. And it's kind of funny that Christopher said that the next big thing will have to be built on something that exists, because Unison is kind of starting from scratch, but it starts from scratch for very good reasons. And we'll talk a bit about that. So yeah, I thought to myself, okay, how hard can it be to build a command line parsing library? And it turned out to be more complicated than what I anticipated, because there's no real standard for those kinds of libraries and how you deal with arguments on the command line. So if we have a look, for example, even just the naming of things. So in Rust, we talk about passing args in general. In Haskell, the naming is a bit more, there are more differences between the names. You have flags, options, arguments, switch. And in Java, it's either people are calling this an option or a parameter, the thing you pass on the command line. So no real standard. Now, if we have a look at the features that such a library can offer, there are tons of different features, and there's not a real standard set of features. So for example, when you pass a value by giving it a name, like dash dash name space value, some libraries also allow you to pass name equal value, for example. So this is something that I supported because it was not hard to support, but not all libraries propose this. And we'll see some in more detail, one of the features that are provided by this library, and that the red crosses are things that could be supported, but that I don't support yet. Now, if we turn to the help and how the help is displayed, here again, we can see many differences between various libraries. So the help is, of course, a very important part of this kind of library. You have all sorts of options that they have different meanings, and you want to know what they mean. So this is one example of a command line application that's using Rust. There's CP, I think, is the one from just man CP. If you run JQ minus H, you will see, for example, one thing that does not appear in other help display. You have precise examples on how to use a command. Then if you run the Snowflake, so Snowflake is a database. If you run the snow command, you will see some help with colors, for example, and nice sections and different typography and boxes. So now people are trying to make even nicer help displays. And I think this one is using Python under the hood. So yeah, no real standard. So I got to choose things that I liked. So let's start with showing you a small example of what you can do with the library. So I want to implement a simple command here that's just going to copy one file from one file path to another file path. And so this is the command I want to parse. Those are the things I want to parse. The thing before the blue box is related to how you run programs in Unison. So that's not really important. So when I run my program with those arguments, I'm first displaying, executing the command is just displaying, okay, I'm copying the secrets file to the stolen file. And I can also run the command by passing the minus help flag. And in that case, there's all the help for the command with description of the command, description for all the arguments and so on. And as you can see, I like colors, so it's all colored. So, okay, now what about Unison? because I use Unison to implement this library. So Unison is a functional programming language, which is very close to Haskell. If you know Haskell, you will be really at home with Unison because it has strong static types that are very reminiscent to Haskell, but it has strict evaluation. It doesn't have any type classes, which is a bit surprising at first. And it doesn't have things like macros or language features. In some ways, it's a very simple functional programming language, very, very bare bones. But it also relies on something that's very new. It relies on using immutable code. So all the code that you produce goes to a database. Each function is hashed. The hash of the function is actually the internal identifier of that function. So that never changes. And that has some very nice and very important properties. When you deploy code, for example, if you ever deploy like a variation or an update of your function, any code that was depending on the older function will never break because they will not depend on the function name, they will depend on the function hash. So this is a very profound property that has impacts on not only on deployment, but also on how we develop the software. Again, just the fact that it is stored in a database has some important repercussions on how we develop with Unison. And it has one superpower. So I said it's a bare bones functional programming language, but it has an effect system. So there are a few languages that support like a real effect system, like Coca, for example, and Unison is one of those. And we'll see how to use this effect system to implement the library. So again, if you don't know Unison, I'm just having a quick look at the syntax. So it's very Haskell-like. You can have a type signature showing you the type of the arguments you want to pass. You can use pattern matching. So you can match an option of a person and extract parts of your data types. There's a shortcut. If you don't want to name the parameter P, you can use cases to do your case analysis, very much like lambda case in Haskell. There are a bunch of literals in the language for lists, for, strings, tuples. There's also a pipe operator that is frequently used in the code, a bit like F#. And then if you want to declare a data type, you give it a name, and then you can declare fields for your data type. So pretty simple. But now there's this new thing, which is the effect system. And in Unison, this is called abilities. And to explain what an ability is, I'm going to make an analogy with the reader monad in Haskell. So if you know a bit of functional programming, you know that there's a way to structure your program so that you can ask for an environment that will be passed later. You can ask for a given value. So this is exactly what we are doing here. The reader ability gives you the opportunity to ask for a value, but this value will be tagged with the effect. It's a computation now. It's just not a pure value. And you can use it to implement add, where you can add a value n to something that you ask that will be provided later. But then the results will be depending on the fact that you read a value from the environment. So this is why we have this annotation in curly braces. And then how to implement this effect. To implement this effect later on, we use the handler. So you handle a computation with different cases. The first case is there's no effect. No one used the ask function. Then you return a value. But if someone called the ask function, then you are going to provide the R value, so to a continuation K. So K is a continuation for the rest of your program. So the first time we call ask in add, the interpreter will go up to the nearest handler, says, oh, I have a value R to provide, and it will call the rest of the program with R to continue the rest of the program. And if there are other effects, and this is the case here because we ask again, then we run reader one more time. So recursively, we run the effect until there's nothing left to run. So if we use this run reader handler on top of add 3, we run reader with an initial value of 2. We ask one time, 3 plus 2 is 5, and we ask then a second time, 5 plus 2 is 7. And what you see here is actually something called the watch in Unison. So if you put an expression with a greater than sign, inside your code, it will automatically evaluate when you modify your code, which is actually also nice in terms of development environment, because that means you have a REPL integrated inside your code, which is a very cool thing to have. So Unison comes up with all sorts of abilities already bundled with the language. So you have abilities to have exceptional behavior, like abort an operation, throw an exception that has a specific type, or just throw a generic exception. There's a state ability, a bit like the state monad, where you can put and get a value. It's called store. You can do I/O with an I/O ability. You can get random values to generate data for your test, for example. There's a non-deterministic ability, because the continuation we use, the K continuation, doesn't have to be invoked just once. So you can invoke it with different values and then collect all the results corresponding to all the invocations, which is a very powerful thing to use. You can stream values, create streams of values using abilities. And also Unison has a very strong offering for deploying services in the cloud. So you can use this to the remote ability to deploy things in the cloud. And yeah, this is another topic, but this is very cool. And this is also modeled as an ability in Unison. So now let's have a look at the library. What we want is to parse strings coming from the command line and make like well-typed object with a source, a destination, and maybe a Boolean telling us if we want to force the copy or not. And in the library, you will declare a parser for those things like this. So we want to produce a copy object with a parser effect, because that thing will come from doing some parsing. And we start by declaring that we want a copy command. We can give some help. So there's a short help and there's a doc help. So curly brace is actually documentation as a first class object. So Unison as a first class documentation object, which is really cool, because when you document your functions, you can put some code in there. The code will be compiled. You can even execute some code, so you can have executable examples in your documentation. That's very nice. And that can also produce some markdown and so some very nice HTML pages. So this is something that I leveraged in the library to be able to get some rich help. And then you have three options: copy, source, destination, and force. And those are three separate parsers that we eventually use to actually do the parsing. So the last line is actually invoking three different parsers to collect the source, collect the destination, and collect the force Boolean. And once we do this, we have a full copy object. So now if we drill a bit about those declarations, like an option, so you declare the name, the short name. So $S is for a character. It's not a string, it's just a single character. The help, and then there are a bunch of declarations under file path, which come from another function with a different effect. We'll talk about that, where you describe how you want to decode values from the command line, how to document them with the type, how to display them. And you can also provide examples for those values. And that's useful to produce the help. And we'll see also how it's important to have those examples later. Most of the time, you don't have to do this yourself, because for most of the data types coming with the base library, they are implemented and supported inside the Potions library, so you don't have to deal with this. There's even something that is pretty nice, which is a format. So most of the time, because we pass strings, it's also nice sometimes to be able to specify exactly which format we expect to have for those strings. So this is also documented. Of course, you can pass your own values on the command line, your own types. So if you have your own type like this, you can use the value DSL, which is an ability, to use the functions like decoder, display with, give an example, and then that thing will be already usable on the command line. And there are also a bunch of combinators, which means that if you know how to parse a value of type product ID, you can know it's easy to make a parser for a list of product IDs by using the list of combinator. And if you know how to parse something of type product ID, but that thing should be actually optional. Maybe it's not passed on the command line and you don't care, it's just none. Then there's the optional combinator that will make it an optional value. And as you can see in the type signature, you start from something that produces a product ID and then it returns an optional of product ID. So eventually you can use different primitives to produce, to declare option parsers. So for options, things that have a name, for flags, things that don't have a name, and for arguments, things that are just positional. And there are variations for all of this. So for options, you can specify, and flags, you can specify different names, which can be useful if you have aliases to an option. So let's say you're not satisfied with the original name that you gave, dest. You want to change it to destination. You can just create an alias for this. There's a shortcut for flags, which is call it, if your type, the type that you're parsing is a Boolean, you can just call that a switch. And for arguments, you can also specify things like the exact position where you expect the argument to be passed. So yeah, there are variations that you can use to do those declarations. But also you can grab, out of the box, you can grab your arguments coming from other places, like from environment variables. So there's a convention. If you put a value in source_file, you will also retrieve the value. But you can adjust this. You can say, oh, actually, my environment variable name is called source, or it's called source file. You can describe what kind of transformation you want from the original option name to what should be the environment variable name. Okay. One more interesting feature that I don't think exists in other libraries is have a direct mapping between an enum type with a flag, because writing minus color red is not that nice. Writing minus red is much more simpler. So it is supported by the library, but as you can see, it's actually a bit more verbose, and there's even some repetition. Red, green, blue, those strings have to be repeated several times. This is typically the places where we would like to have some kind of macros in Unison, but there are no macros in Unison. So you have to deal with the repetition. And all of this, the fact that you're using this kind of flag in a mapping is also reflected in the help, where you will see all the different values that are accepted on the command line. Another cool thing that we can do, and we will see how it's implemented, is to repeat options. So you don't have to pass an option name just once on the command line. You can pass it several times. And in that case, we collect all the values into a list. And to do this, just put an S at the end of your declaration. And now you will parse for several values instead of just one, which I think in terms of DSL design is actually quite nice. Just put one letter and you have just the kind of behavior change that you want eventually for your parser. What I described so far was just to parse one command, but many command line applications are more complicated than this. You have several commands, and you can combine different parsers for different commands into top-level commands, like in that case, a file, fs file system command. And we use this alternative operator to say, okay, I want to parse a copy command or list command or grep command. You will find this kind of operator. If you know Haskell, you will probably feel very familiar with this kind of alternative. And then what that means is that if you run the help for the fs command, because it's a top level one, you will have the list of all the possible commands. And if you call -minus help on a specific command, you will see the help for that specific command. One last feature, and then we go to the implementation, is if you make a mistake in one argument, you type something that is almost the right thing, but not the right thing, you will be told by the command line, oh, maybe you made a mistake, try this, that should work better. Okay, so how do we implement all of this? And really the magic sauce here is to use Unison abilities. And we will see like 3 different contexts where we use this superpower given to us by Unison. But first of all, the question is, what is the data model that we use to support all those declarations? Because what we've seen so far was just declarations of things we want to do. We are very decorative, but we need to put all this information into some structured data. We have things that are almost the same, like an option, a flag, and an argument. They're almost the same, but they have small differences. Like options and flags, they have names, but not arguments. A flag has an active value. All of them can have an optional default value. So there are differences between all those things. So the way I choose to represent this was to have one data type called option. And all the differences are actually embedded in this specific thing that encodes the differences between like a pure option with a name, an argument, or a flag. But otherwise, it's almost the same data structure. So now the question is, how do we come from declarations like this, describing a flag, to a value of the type option with all the flag information? And if you remember, I said you have ability declarations, and for each ability, you need to have some handlers. But all those declarations actually come from different abilities. So there's a naming ability, providing you with support to deal with names and to declare names. But in the library, I decided to have many abilities corresponding to different aspects of what I wanted to build. So there's a flag ability, an environment ability, and so on and so forth. But eventually, we are going to grab all of this information and put it into the same object. And as a library user, you don't really have to worry about the fact that there are many abilities that we handle. They are just accessible under the same namespace, which is called DSL. So the question is, how can you write an interpreter that's going to make an option, taking some kind of effects where possibly we have some positional DSL calls, some flag calls, some repeated calls, some name DSL code calls, and so on, into this option data type that we see in the lower corner, right corner. So this is what we want to do. And that's exactly how we write it. So we go through all the cases. Okay, if you make a call to decoder, we take this information and we set the decoder option on an option value. And we do this for all the calls that you potentially make. We grab this information and we collect it into one object if you want. The thing is, it's not as straightforward as it is, because we could have some errors in doing so. Eventually, you might produce an object that is not correct. So you might say, I want a flag, but you are not giving an active value for that flag, a value that will be used if the flag is present. So this construction might fail. So we are in the case of a builder pattern, like you could find in languages like Rust or Java, where you chain methods and you say with name, with flag, with environment variables, and so on. And eventually you called with build, and that's going to build what you want and validate it at the end. So in order to do this, we actually do this in 2 steps. We first collect all the information into an intermediary data type where we don't care about the validity. We just collect information. And then there's a validate option that, depending on what you want to build, if it's a flag, an argument, or an option, it's going to validate that all the information is really there. And if it's not there, it's going to raise an effect, an exception effect, using the exception ability to tell you that that didn't work. And it's going to report it on the command line. So that's one use for abilities, for having a DSL where we purely specify what we want, and then interpreting it into an object, having all the values and checking them. There's another use for that thing, which is actually interesting, because in that case, we interpret an expression with all those calls, but we interpret it into the same effects with slightly different types. So when we do repeated options, when we say, instead of an option, I want to parse options, I want to parse several values of that type on the command line, what we do is actually write a handler that is going to say, okay, now if you have a decoder ability, method, if you want, we are going to transform this decoder decoding just one value into a decoder that's going to decode several values. Same thing for how we're going to display the help for the value type. Instead of displaying just the normal value type, we're going to put an asterisk at the end. So what we are doing is interpreting some effects with other very similar effects with just slightly different types. So this is another use of handlers in that situation. But we are not done, because now we just have an option data type that doesn't do anything by itself. It just has a bunch of declarations for how to decode values, what kind of help we want for the option, and so on. Now we want to make a parser. So there's, again, a small language to arrange those option parsers and to be able to build commands out of other commands and so on, and to do this alternation for use this command or try to parse with this command or try to parse with this other command. And again, this is another ability called the parser ability. And this time, writing a handler for this ability might mean, okay, do the real parsing. So take some inputs, some strings, take an expression having this parser ability with all those option declarations and so on, and now do the actual parsing. And to do this, we are going to use other effects. So the parsing might fail. We might use some values from the environment. And we will need to store the state of what we have currently parsed and not parsed. So there's a state effect that is used. And eventually, what we hope to get at the end is a command that was built out of the inputs. But that's not all. So we can grab one parser expression, transform it into an actual parser, doing all the parsing. But we can take the exact same expression, this time producing the help for the command. And to do this, we define what's our target. In that case, we want to produce something from another type, common help. And we want to write another handler. And that other handler is going to take the same parser expression, the same computed expression with the parser effect. And this time it's going to produce the common help object. And to do this, it's going to go through all the cases. And every time it has some help information, it's going to produce it. This is actually not so trivial, because there's a bit of recursivity in all the calls that you can have, because commands can nest other commands, but it's doable. And to do this, again, this is handling all the cases for the parser ability. And in particular, this is where we see why it's very important for each option to give at least one example of the value of that option, like a file path, because we have those continuations K. So if we want to analyze all this expression, every time we have a continuation, we have to give it a value. But in this case, we are just producing the help. There's nothing coming from the command line. We don't have any input value. So we have to have some kind of dummy values to be able to give to this continuation, so that we can continue getting to the next declaration, in our program, and so on. Because we have those calls to source, destination, and force. But eventually we can get there and get some help. And then, I mean, once we have this help, we can transform all this help into a doc inside Unison, this doc data type that we have. But instead of displaying it as HTML, I'm using a library called Terminus, which helps people interact with the terminal. And this is where we set all the output in terms of what font should we use, what colors should we use, and so on. And this is all configurable. So there's a palette data type that you can use to change the colors. So if you don't like the colors that I'm using, you can inject other colors and you will get other colors. I think, again, this is in a way a nice testament to functional programming, where there are like different steps in your processing pipeline. And if you don't like one step, you can just change it with something else. The last thing is how this algorithm for telling people that they possibly made a mistake, how it is implemented. It was not very fancy. I think I had a look at the Rust implementation, and they were using this algorithm, which is nicely documented in a blog post. And again, this is one place where functional programming shines. Just take a formula, implement it, add some tests, and here you go. And you have to select some weights, but it gives some pretty good approximation of when something can get some better suggestions. Okay, so I know there are many things that probably went maybe a bit over your head if you haven't seen Unison or abilities or effects integrated to a language before, but I hope that gives you a good idea. I just want to recap quickly. So we started with a library with some DSLs for purely declaring what we want to parse, how we want to document the parsing, and then going step by step into transforming those declarations into some values on some data types, and then having some expressions that we can reinterpret in different ways to produce different things, either a parser, an actual parsing function, or some helps for the documentation. So this is very powerful. Now I just want to focus a bit about Unison and the experience that I had in programming this library, because it was the first time I was programming something a bit larger than what I produced before. The full library is around 8,000 lines of code. Some of those lines are kind of generated by Unison, but it's a large library. It was my first large library and large experience with it. So before I talk to you about what was good, what was not so good, I need to show you what it looks like when you're programming with Unison. So basically you have two panes. So one is your text editor, where you can grab some functions out of your database to edit them. And you say, edit this function, and it will be in your editor. And on the right side, you have a bunch of commands that you can run. So you can say, now my code on the left side is okay. I want to update it. That means push it to the database to save it, commit it, and you can run some tests, and you will have all your tests. As you can see here, all those tests that I've just executed were executed instantly because they were cached. This is one of the very nice side effects of having hashed functions inside your database. That means if we detect in Unison that an implementation didn't change, that this has no impact on your test, and if your test is pure, there's no problem. That means that your test will still pass. So that is a very cool feature. And this is basically your environment. You don't have code as file and as a bunch of files into directories and so on. Everything is into the database. And that has some nice properties, and that creates some issues. So one of them is that I found was kind of annoying was readability. So I write my code, I update it, it's in the database, and then I say I want to edit it again into a new file, a new buffer if you want. And it comes out formatted in ways that is not necessarily nice. For example, I cannot choose the column width. For example, it's 80 by default, which I personally find too small. If I add some new lines in between inside a function, those new lines will just disappear, because Unison doesn't really care about text. It just thinks about, ASTs. Text is not something that's important to Unison. So I think that's not so nice. So I personally developed a few workarounds for this, but that's not great. Also, comments are also not a thing, because comments are not really executable. So there are workarounds to add comments to your code, but it's not out of the box. Navigating code can be a bit uneasy in a way, because you cannot really click on a function and this will automatically bring you to another file containing the function you wanted, for which you wanted to see the definition. You go to the right side of the window and you say, okay, I want to view function, and it's going to fuzzy find all the functions that you can view. There's also a find command that you can use which is a bit like Google, where you can specify the type of the function. This is quite helpful, but in a way, the navigation could be definitely improved. And if you forget to exit the fuzzy finding and you were now making some modifications to your code, all the right side of your window will be a garble like this, which is not so great. Similarly, because you have this divide in the windows, when there's a type checked error, so every time you change your code, it's type checked on the right side. And so you will see those errors accumulating, but that means that if you run a test and there's a test failure, And then you say, okay, I'm going to fix my code. Then the code is type checking, maybe has some mistakes. And the failure will progressively disappear from the right side, which is not great because now you have to scroll to see what was my failure again. Not so great. And another effect of having those windows and not having all the code available at the time is that when you update a function, that might have some ripple effects on some other functions that already exist. And their function will not be updated in the database unless everything compiles. So what Unison does in that case is that it brings all the code that needs to be modified, that has some potential conflicts, into your window, and then you fix compilation errors, but you can only fix them one at a time. And in large files, that means that you will sometimes jump between the beginning of the file to the end of the file, which is not great. That also affects performance when you have lots of code. And it's a bit error prone because if you do this a few times, you will end up jumping around and having more code adding on top of existing code. Sometimes you just don't know where you are, what was up to date, what did you change, what was accepted, what was not accepted. That I found that a bit tricky personally on a large project like this. I must mention that refactoring records can be also annoying because records are not really first class in Unison. They are much more like a bunch of generated functions. So for example, removing a field from a record takes a few commands. It's just not something that's just one command away. There's no notion of commit. So you say update this function, but you cannot give a message explaining why you want to update the function. All of this is coming to future Unison versions. We know about those issues, but right now you don't have this. And also, if you want to rerun your tests and check if they would break if you have a modification, you have to first update your function. So that means commit it to your database, and then you can run the test. But then if your tests are breaking, you need to, don't forget to unupdate. I mean, remove that version of the function from the database. So, I mean, you can create branches if you want to just run a quick experiment for this, but branches are not really made for that. And there's also no way to see the documentation right as you are modifying it, which is a shame because documentation is very nice in Unison, and you need to, there are several steps necessary to display the latest version of your doc. So not great. So what I'm saying here basically is that programming with Unison would be a lot better with many more windows. So one window where you see your type check errors, one window where you see your watches or your test, one window for the documentation, one window for searching and having a list of everything you want to search for. And in general, having more navigation actions to go from one function to another, and having some status elements on your functions. So if you modify something, you should be able to know if that thing has been committed to the database or not, and what are the repercussions right away on other pieces of the code. So all of this will make a much better IDE. So yeah, my plea to the Unison team is give us a better idea, because there's a potential to have a great idea with Unison. We are not quite there yet. But I have some good news. It's actually coming. So the Unison team is working on it. So this is, for now, they have something that is only read-only. So you can open functions, and they will open in some small cards like this, where you can see tabs with the code on one side, the documentation on the other side. So you can instantly see the modifications if you modify the documentation for a given function. So I think the future is quite nice for Unison as a programming language. And well, I think that's it for today. Please let me know if you have any questions.
Thank you very much, Eric. We had a question in the chat, from the YouTube chat.
Yep.
I love the idea of Unison as a language, but the whole development environment seems quite rigid. But you covered this in the end and said it's coming. So yeah,
Indeed. Yes.
It is. How come you came into working with potions?
That's yeah. I was trying to implement. So Unison is very strong for building microservices and applications in the cloud. And one strength is that you can use Unison programs to deploy your code. No YAML files, no silliness like this. And those services will communicate together where you don't need any serialization. You just say, I want to communicate with that service, and there's no serialization involved. There's no serialization to store your data. So the cloud offering, again, is very interesting. So I started developing an application for myself to interact with my bank accounts and my accounting software.
Mm.
And I wanted to be able to pass on the command line things like my API key and stuff like that. And there was not really a way to do this. I actually started implementing in Haskell a prototype of a command line option library. So I found that the domain was interesting. So
Mm.
yeah.
Interesting. What are you working with day to day, Eric? I guess it's not Unison your your
No, so
day-to-day.
I'm working for OCAM,
Yeah.
and we are using Rust and Elixir
Mm.
to provide some software to run secure communication using secure channels between different systems. And it's particularly useful if you have some private data that you want to put inside a query from another system, but you don't want to expose your private database or your private system to the internet. And so what we offer is some kind of relay in between where the communications go through the relay and nothing is really exposed on the internet.
Mm.
And we do again, we use Rust and Elixir to do this.
It sounds like a nice environment. Have you worked with more FP languages
Oh
than
yeah,
Rust
so
and Elixir?
in my previous company, I've used Haskell a lot
Mm.
to do a system that was like a distributed database, if you want, using more or less a blockchain, like a distributed ledger using Haskell. And before that, I used Scala a lot. So
Oh,
yes,
yep.
I'm a functional programming lover.
Mhm. I hear that. Did you start with functional programming straight out of university or college,
Oh,
or?
not at all. I suffered a lot with C++ and Java for a long time
Okay.
before giving up and thinking that it was more than enough and I should learn Scala. Yeah, I discovered Scala in 2006 or something, and implemented one of the test libraries for Scala and really fell in love with the language and the functional programming approach. I actually re-implemented that library twice. I mean, three times. And the second time was because I could not deal with concurrency. I started with lots of mutation. I didn't know how to deal with concurrent execution of tests. And I thought, oh, I need functional programming to do this properly.
Mm. Interesting. Again, thank you very much, Eric, for coming on and presenting Unison, and for always also interesting background. I think a lot of people share the frustrations with working with some Java, C++ stuff, and then finding some functional programming languages and never looking back. Yeah.
Exactly.
Yes.
Cool.
Yes.
Thanks, everyone.